Okay, so for this problem, I picked my angles to be, I had A be 30 degrees, which is the same as pi over 6, B to equal 150 degrees, which is the same as 5 pi over 6, C is 135 degrees, or 3 pi over 4, and D was 225 degrees, or 5 pi over 4. And so, for my A and my B values, I figured out what the sign of each of those values would be. So I got the sine of 30 to equal 1/2, and then the sine of 150 to also equal 1/2. And so then I went on to figure out what the cosine of my C and D values would be. So I got the cosine of 135 to equal negative square root 2, and the cosine of 225 to equal negative square root 2 over 2. And then the next thing that I did is I removed the degree values from all the equations and replaced them with theta. After removing the degree values, I made all of the equations equal 0. So at this point, I had 4 equations. The equations are 2 sine theta minus 1 is equal to 0, and then again 2 sine theta minus 1 is equal to 0, and then 2 cosine theta plus square root 2 is equal to 0. Sorry, the past two are equal to 0, not theta. And then also 2 cosine theta plus square root 2 is equal to 0. And since two of the equations repeat, I was just able to use one of each of those equations. And then since the equations I found um, are essentially the equations to find the angle measures, I was able to multiply them together to get one equation. So when doing this, I got 2 sine theta minus 1 times 2 cosine theta plus root 2. So after multiplying those out and FOILing them, I got 4 sine theta cosine theta plus 2 root 2 sine theta minus 2 cosine theta minus root 2. So now at this point, I was ready to start using my identities. So the first identity that I was able to use was the identity that sine 2 theta is equal to 2 sine theta cosine theta. And I was able to use that for the 4 sine theta cosine theta part of the equation. In my equation, the coefficient is 4, so I just had to multiply the identity by 2 to get it to fit. After plugging in that identity, I got 2 sine 2 theta plus 2 root 2 sine theta minus 2 cosine theta minus square root 2. Next, I was able to use the identity for the 2 square root 2 sine theta portion of the function. This identity was that the sine of theta is equal to 1 over cosecant theta. After plugging in this identity into my equation, I was able to get 2 sine 2 theta plus 2 root 2 over cosecant theta minus 2 cosine theta minus square root 2. And then I was finally able to use an identity for the minus square root 2 portion of the function. I know that 1 is equal to cosine squared theta plus sine squared theta, and since the negative root 2 portion is technically multiplied by 1, I was able to plug in that identity for that 1. After plugging the identity and multiplying the that whole identity by root 2 just by root 2, I got my final equation to be 2 sine 2 theta plus 2 root 2 over cosecant theta minus 2 cosine theta minus parentheses square root 2 cosine squared theta plus square root 2 sine squared theta. And then finally, I put a limit on my function to be 0 is greater than or equal to theta, which is greater than or equal to 4 pi over 3. I did this limit so that that when graphing the equation, I would only get the 4 angle degrees that I found in the beginning.